Hey guys, thanks for clicking on the video. It's the mechanical engineering tutor here, and today I'm going to take you through how to calculate the moment of inertia of an I-beam. The I-beam in question today is 100 millimeters for the flange, that is 9 millimeters thick, and the web is 12 millimeters thick, and the other part is also the exact same. So we have symmetry with this cross section. And the first thing we're going to want to do is calculate the centroid. And the formulas we need for this are the x position, so what these formulas are basically saying is we want to sum up all the individual areas and how far they are from a certain point. So for this, what we're going to do is mark down the middle part of each section. And we're going to label this one as shape 1, 2, and 3. We're going to split them off here and here. So first step is calculating the area for each shape, each part. So for 1, A1 is equal to 100 times 9. Now let's do A2, which is equal to 150 times 12. And this is equal to 3,000. And because A1 and A2 are the same, we'll just write down 900. Okay, now let's calculate the x point of the centroid. So okay, so this is the formula expanded out, and we need to find out what x1, x2, and x3 are. So let's find that from our cross section. So what we're going to do is we're going to choose an arbitrary point on the cross section to label 0, 0. And that will be this corner here. And these are where we will take our measurements from. So for x1, we want to measure how far shape 1 is, the center of shape 1 is from this point. So that would be x1. And that is 50. So we know x1 equals 50. And I know that because it's just half of the top, which is 100. So now let's find x2. And x2 is also 50 because we're going the same distance. It's the center of each shape is in the same spot. So actually what we can write is x1 equals 50 millimeters, and this is also equal to x2 and also equal to x3 because the center of each shape is on the same spot on the x-axis. So we can write that. So now let's calculate our x. So So when you calculate that all out, it's going to equal 50 millimeters. And once you get good at doing these kind of things, you can tell that the x is obviously going to be 50 because it's symmetrical on both sides and 50 is right in the middle. That's just makes sense. So now we're going to do the same thing for y. The y one will be the same formula. So a1, y1, a2, y2, a3, y3. Okay, so now we got to find our y's. So we'll measure it from the same spot. The y's are going to be different though because the shapes have different y-axis. So we'll do y1 from this point all the way up to the center line of this is y1. So how do we calculate y1? So y1 is equal to 9 plus 150 plus 9 over 2. And this equals 163.5. So now we'll do y2. So I forgot to add in the center line for this. All right, and y2 would be, just make this go all the way across so it's easier to read. All right, so y2, let's do y2. y2 is from the same spot, go up to the center, y2. So how do we calculate y2? y2 is equal to 9 plus 150 over 2. And this equals 84 millimeters. Okay, let's do one more, y3. It's the last one. y3 is just up from the same spot to the center. And y3 is just equal to 9 over 2, equal to 4.5 millimeters. All right, let's calculate where y is. All right. And when you calculate that all out, it equals 84 millimeters. So now we know our centroid location is equal to, put it in XY coordinates. All right, so let's go label that. And we'll label that with red. And it's going to be right in the center because we've got symmetry. So this makes that easy when you're doing I-beams with the same with flanges. So let's continue on now that we have our centroid location. The things we need to find now are the x moment of inertia and the y moment of inertia. So the formulas needed for those are, so when you're finding the x moment of inertia, I'll just add a page here. Could do that one first. This is Ix. And Ix is equal to Ix1 plus Ix2 plus Ix3. And those are the Ix's of each of the individual shapes. And for one of those, Ixi equals base times height to the 3 over 12 plus the area times HYI squared. And I'll explain what h is. So let's find our h's. Let's find... Okay, so h essentially is the distance from the center of the shape, center axis of the shape, to the centroid. So x1 will be, so all the x's, I will explain, the same as before, will be 0. So from the centroid here to the centroid here is 0 distance in the x axis for all of these shapes. So xi equals 0 for all of them. Now let's find our y's. The y's will be a bit different. So hy1, label these in green so you can tell the difference. So hy1 is from the center here all the way down to the centroid. And now the centroid just happens to be in the center of shape 2, but that's okay. So this is hy1, and hy1 is equal to 150 plus 9 150 over 2 plus 9 over 2, because we have 50 cut in half, that's this length, and then we have 9 cut in half, that's this length. So you add those together and you get 79.5. Now, one thing you need to be careful of when doing the h's is, because this is going down towards the centroid, that needs to be negative. So we'll add a negative there. Just got to keep track of that for when you're doing the product of inertia, especially with unsymmetrical shapes. So let's find hy2. And hy2 is going to equal 0 because the centroid is right in the middle, so it can't go anywhere. That's just based off looking at the shape. And then hy3 is equal to that, hy3. And based off looking at it, you can tell that it's going to be the same. Half of 150 plus half of 9 is going to equal 79.5. But the difference between these two is this shape is below the centroid, and this one is above. So this one has to travel upwards to get to it, so it's going to be positive. All right, so let's continue and calculate each moment of inertia for the x. So let's do x1. And x1, we have the base, which we know is equal to 100. And we have the height, which is equal to 9. All divided by 12. And then we're going to add the area, which is 900, times hy1. So hy1 is equal to negative 79.5. Now the negative doesn't matter for these calculations because it's squared. So when you calculate that out, you're going to get that. So let's do the same thing for the second shape. So we know that the base is 12. And we know that the height is 150 to the 3 over 12 plus the area, 3,000, times h, but we know h is 0, so 0 squared. And this equals all right, let's do the last one. Oops. And it's going to be the same as the first one, 100, 9 to 3 over 12 plus 900. All right. So to get Ix now, remember we have to add all those up. So adding all those up, Ix equals 14763,600 millimeters to the 4. And putting that correct notation, Ix equals 14.7636 times 10 to the 6. And that's our final answer for the X moment of inertia. All right, so let's do Y. Same formula, Iy equals Iy1, 2. And the formulas are the same. So we will, for this, because we know that all of the, well, I guess I'll write it down for you so you have it. So Iyi equals the height. So you're basically flipping your axis. So your height and your base are going to change. So your height times the base to the 3 over 12 plus AI times H, nope, not Y, HXI squared. And we know that this equals 0 for all of ours, so we can just cancel that out for all of our calculations to make it easier. 1 equals, so we remember the first one was 9, so let's flip those. 9 times 100 to the 3 over 12 plus area of 1 times 0 squared. Iy1 equals 75. All right, let's do Iy2. Again, we're just going to flip those so we know that it's 150 times 12 to the 3 over 12. Say 2, 0 squared equals. All right, let's do the last one. And we know this is going to be the same as the top one. And if we add all those up, we get our final answer of and that's our final answer for Iy. Now the last thing to do is calculate the product of inertia. And because this shape is symmetric, I know from experience that the product of inertia is going to be 0. But I'll take you through how to calculate it so you know for other shapes or if your I-beam is unsymmetrical, so you can figure it out. So this is multiplying the HY by the HX and the area, and you have to do that for each one and add it up. So let's just do it and prove that it equals 0. Okay, so IXY1 equals 900 times HY1, which we remember calculating negative 79.5, And this is why you got to keep track of the negatives, because your product of inertia can be negative, and that's okay. But we also know that all of the hx's are 0. So this equals 0. Let's do ixy2 so you go 3,000 times 0 times 0 equals 0. Ixy3 equals 900 times positive 79.5 times 0 equals 0. And guys, that is how you calculate the moment of inertia and the product of inertia for x and y axis of an I-beam. If there's any questions, please feel free to comment and ask. I will do my best to get to them. And please like and subscribe, because if you're going through mechanical engineering, this is going to be a YouTube channel. It's going to help you a lot. I'm going to go through my whole course because I'm a fresh graduate of mechanical engineering, and try and help you guys out with the stuff that I struggled on that teachers aren't very good at teaching. And this is one of those things. So I hope you enjoyed, and thanks for watching.